Welcome to Aptitude for Placements, and my name is Ranjit. I have conducted this aptitude training program at various engineering colleges all over India, and every year thousands of students get placed by attending this aptitude training program. Here you will find all the questions that are commonly encountered in most of the aptitude tests. These are the questions that keep on repeating in many of these tests. So just familiarize yourself with all these questions and you will have a clear advantage when you attempt your actual placement test. Let's start. Let us start with the topic boats. Now questions on effective velocity, it usually comes as boats. Now you have a lake here, lake or still water or stagnant water, that is water does not move. And you have a boat here, and the boat in still water or in stagnant water, it can move at b kilometers per hour. So this boat in still water, it can move at b kilometers per hour. Now generally when you have questions on boats, the boat will be in a river, and as you know, the river always flows down. Now this river is flowing down at r kilometers per hour. Now this same boat is here. Same boat in the sense that in still water it can move at b kilometers per hour, and it is going down along with the river. Now when it is going down, it is called as downstreaming, and when it is downstreaming, effective velocity will be b plus r kilometers per hour, where r is the speed of the river and b is the speed of the boat in still water. And the boat need not always be going down, it may be going up against the river. Now when it is going up against the river, it is called as upstreaming, and effective velocity will be b minus r kilometers per hour. When the boat is downstreaming, effective velocity is b plus r, and when it is upstreaming, effective velocity is b minus r. Then of course you have the basic formula, that is distance by speed gives you time. And this speed, when it is downstreaming, it will be b plus r, and when it is upstreaming, effective velocity will be b minus r. Then while traveling in the river, there will be some ports by the side of the river, port where the boat can berth. Now let us say port 1, port 2. Now whether you are downstreaming or upstreaming, you can see that the distance between the ports is always same. So let us start with the questions now. A boat goes down the river and covers the distance between two ports in 4 hours, while it covers the same distance upstream in 5 hours. If the speed of the river is 2 kilometers per hour, find the speed of the boat in still water in kilometers per hour. So you have, I can draw the river like this. The river, as you know, it is always flowing down. A boat goes down the river, that is, it is downstreaming and covers the distance between two ports in 4 hours. So we'll mark the ports like this, port 1, port 2. Now whether you are downstreaming or whether you are upstreaming, you can see that the distance between the ports is same. We'll just take it as d. So first we'll form the equation for downstreaming. A boat goes down the river and covers the distance between two ports in 4 hours. Time required to cover this distance is 4 hours. So you have the basic formula, distance by speed gives you time. This is a basic formula. So distance between the two ports, we'll take it as d. Now when you are downstreaming, effective velocity is b plus r, and the time required is given as 4 hours. So it goes down the river and covers the distance between two ports in 4 hours. So time required is 4 hours. So this is the first equation that we have. Now let us form the equation for upstreaming. While it covers the same distance upstream in 5 hours. So whether you are downstreaming or upstreaming, distance is same d, and when you are upstreaming, effective velocity is b minus r, and when you are upstreaming, it takes 5 hours. So time is 5 hours. So this is the equation for upstreaming. upstreaming effective velocity b minus r and downstreaming effective velocity b plus r, where b is the speed of the boat in still water and r is the speed of the river. If the speed of the river is 2 kilometers per hour, find the speed of the boat in still water. So r is equal to 2. So r we can substitute 2 here. So here you will get a d is equal to 4 into b plus 2. Here d is equal to 5 into b minus 2. So you have just one equation and one unknown. B is the speed of the boat in still water, and that is what we need to find out. Find the speed of the boat in still water. So here 4b plus 8 is equal to 5b minus 10. I'll just bring b to this side. So you will get b is equal to 8 plus 10, 18. That is 18 kilometers per hour. That is the speed of the boat in still water. So option A, 18. A boat goes down the river and covers the distance between two ports in 6 hours, while it covers the same distance upstream in 9 hours. If the speed of the river is 12 kilometers per hour, find the speed of the boat in still water in kilometers per hour. So I can draw the river like this. Now the river, as you know, it always flows down. And by the side of the river, some ports are there. Let us say port 1, port 2 and so on. Now a boat goes down the river, that is it is downstreaming, and covers the distance between two ports in 6 hours. So whether you are downstreaming or whether you are upstreaming, distance between the ports we can take it as d. Distance is same. Now let us form the equation for downstreaming. Now you have the basic formula, distance by speed gives you time. So let us substitute into this equation. It goes down the river and covers the distance between two ports in 6 hours. So distance is the distance between the ports, we'll take it as d. And when it goes down the river, effective velocity is b plus r, where b is the speed of the boat in still water and r is the speed of the river. And the time required is 6 hours. This is the equation for downstreaming. While it covers the same distance upstream in 9 hours. Whether you are downstreaming or upstreaming, distance is same, and when you are upstreaming, effective velocity b minus r, and it takes a longer time, 9 hours. So this is the equation for upstreaming, effective velocity b minus r. Speed of the river is 12, so here r is equal to 12, here also r is equal to 12. Now we need to find the speed of the boat in still water. B is what we need to find out, so we'll eliminate d. Here d is equal to 6 times b plus 12, r is 12. Here d is equal to 9 times b minus 12. So you have one equation and one unknown. We just need to solve and calculate the value of b. Here 6b plus 12 into 6 is equal to 9b minus 12 into 9. So 6b I'll bring it to this side, so you'll get 3b. 3b is equal to 12 into 6 plus 12 into 9, or b you will get it as 12 into here 3 divides 2 times, so 12 into 2, here 3 divides 3 times, 12 into 3, that is 12 into 2 plus 3 is 5, 12 into 5 is 60, so 60 kilometers per hour. That is the value of b, that is the speed of the boat in still water. You will get it as option D, 60 kilometers per hour. A motorboat can travel in still water at 5 kilometers per hour. So we'll mark all this data here. So speed of the boat in still water is b, and that is given as 5 kilometers per hour. In a river flowing at 1 kilometer per hour, speed of the river r is equal to 1. It goes 24 kilometers upstream. So distance between the starting point and the end point, that is d, is equal to 24. So initially it travels this distance 24 kilometers upstream and then comes back to the starting point. Find the time taken by the boat to cover the full distance. So you have the basic equation, distance by speed gives you time. Now we need to find the time taken by the boat to cover the full distance. So first we'll form the equation for calculating the time required for traveling upstream. Now when you are going upstream, distance is 24. That is, whether you go up or down, distance is same d. And when you are upstreaming, effective velocity is b minus r. So this is the time required for upstreaming. Now we need to find the total time taken by the boat. So this is the time for upstreaming plus time for downstreaming. Whether you are upstreaming or downstreaming, distance is same d by effective velocity b plus r. So this is the time required for upstreaming plus time required for downstreaming. And the total time is what we need to find out. Here d is equal to 24. B minus r, that is 5 minus 1, that is 4. Plus d is 24 by b plus r, 5 plus 1, 6. So this is the time required for upstreaming and this is the time required for downstreaming. So total time we'll find out. Here 4 divides 6 times, 6 divides 4 times. So 6 plus 4 is 10 hours. So total time is 10 hours, option A. A motorboat can travel in still water at 8 kilometers per hour. So I'll mark all the data here. Speed of the boat in still water, B is 8 kilometers per hour. In a river flowing at 4 kilometers per hour. So speed of the river R is 4. It goes 60 kilometers upstream. So distance that it covers is 60. And then comes back to the starting point. Find the time taken by the boat to cover the full distance. So you have the basic formula, distance by speed gives you time. So let us use this formula, and first we'll calculate the time required for traveling upstream. It goes 60 kilometers upstream. Now when it goes upstream, the formula is like this. Distance by speed gives you time, and speed or effective velocity is b minus r. So distance by speed gives you time. This is the time required for traveling upstream. And then comes back to the starting point. And find the time taken to cover the full distance. This is the time required for upstreaming plus time required for downstreaming. Whether you are upstreaming or downstreaming, distance is same d by effective velocity b plus r. So this is the time required for upstreaming plus time required for downstreaming. This is the total time. Here d is equal to 60, b minus r, that is 8 minus 4 is 4, plus d is equal to 60 by b plus r. 8 plus 4 is equal to 12. Here 4 divides 15 times, here 12 divides 5 times. So total time is 15 plus 5 is equal to 20 hours. So total time required is 20 hours, option C. When a boat goes upstream, it has an effective speed of 5 meters per second. Now when it is going upstream, effective velocity is b minus r, and this is given as 5 meters per second. And when it goes downstream, its effective speed is 10 meters per second. Now when it goes downstream, effective velocity is b plus r, and this is equal to 10. Find the speed of the river. So you have these two equations. I'll just add it up. You will get 2b is equal to 5 plus 10, 15. Or b, you will get it as 7.5. b minus r is equal to 5. B is 7.5. 7.5 minus 2.5 gives you 5. So r has to be 2.5. That is the speed of the river. That is option A, 2.5 meters per second. Let me briefly explain how to prepare for your aptitude test. First of all, you need to familiarize yourself with all the questions that have been worked out here. These are the questions that keep on repeating in many of the aptitude tests. After that, you need to attempt practice tests. According to me, you need to attempt at least 10 practice tests before your actual placement test. Here, I will be giving you 10 practice tests, and these practice tests will be ideal for you to improve your test scores. The 10 practice tests are available at a cost of only rupees 200. So all that you need to do is make a payment of rupees 200 either through Google Pay or through Phone Pay or through Paytm, and you will receive the 10 practice tests. The details of the payment comes next.